Hey, hi folks, I'm Dan. This is Cole. We're with the FTC University Challenge, Team CU Hyperloop. I'm going to be going over a little bit of our initial brainstorming and strategy going into the challenge itself.
Yep, we're going to talk about scoring, and we're going to talk about what we want the robot to do.
Perfect, so let's hop into it.
So, let's just start from top left. So,
Yeah, I'm autonomous.
Just looking at our plot here, we've got autonomous period, which is 30 seconds, the driver controlled period, which is 2 minutes, but then it's split up between driver and then the end period, which is 30 seconds long at the end. And then we have the different types of scoring. So we have the wobble goal being moved to the zone, so that's available in the autonomous period. And then the wobble goal being moved to the end zone, which is worth 5 points at the end period, and then 20 points if you move it over the top of the wall.
Yep.
And outside of the ring. Then in the end period, you can get 5 points for placing rings onto the wobble. It doesn't look like you need to put it on the ring, just fully supported by the wobble.
Yeah, as long as it's not touching the ground, I think you're good.
Yeah. And then also during the autonomous period, you can get 5 points by parking on the launch line.
It's just that white line.
The white line. So I guess that's, yeah.
Yeah, launch.
And now we've got power shot targets, which are the little 3 little pipes that you're able to knock down by shooting at them. And you can get 15 points for that during the autonomous period and 15 points during the end period.
And they are reset, so cool.
Yeah, reset during the driver window. But I don't think they're reset during auto and end.
I don't think so either. And I also think you can only do it 3 times. We haven't read the full rules yet. We've pretty much just watched the video. But I think at a maximum, your lines can knock 6 pipes down.
Yeah, 45 points in each time period.
Cool.
Finally, we've got our goals, which is kind of the most important or main scoring element. So for the low goal, there are 3 points available during auto, 2 points in driver. In the medium goal, which is on the other side of the field, the opposite side of field to your goal, you can get 6 points in auto, 4 points in driver, and then finally the high goal, which is back on your side of the field, you get 12 points and 6 points in auto and driver, respectively. So starting at the top.
Well, real fast, I think we also want to mention, we are doing the University Challenge, so we only have a weekend to build or to design, build, test, redesign, and then actually compete. So what we're going to be able to do is going to be far more limited, I think, than what most FTC teams are going to be able to accomplish through the whole season.
Yeah, so I guess to put that more bluntly, we're going to make compromises that other teams that have more time probably shouldn't make.
Sure.
So during the auto period, so there's the wobble and we need to move it to a zone, and that zone is randomized, and we're able to tell which zone we need to move to by how many rings are in front of us.
Right.
So I don't really know if we want to do vision. So what that looks like though is our robot. This is the top view. So here is our robot starting off on the start line, and then we've got some rings in front of us, or not in front of us, and they correspond to. This is not the right setup for these. I don't think. Might be the reverse.
Here. Yeah. A and C here.
C there.
Yeah.
Okay. And then the amount of rings corresponds to which zone we want to be in. But we don't really want to do vision this weekend, do we?
Right. Yeah, I don't think so. Neither of us are very experienced with computer vision stuff. So that would be tough. But I think you can do it a different way too, though, right? Because if you can tell by the height of the rings.
Sure.
Which ones are where.
Yeah.
So if you had some way of determining, like if you could see how many rings were stacked up by putting like some sort of sensor that shot forward like at one high level, you could definitely discern between whether there's one there or whether there's rings there or no rings.
Okay, so you're saying, we have a stack, and then you just shoot out a LiDAR, and then if it sees something, that tells you that there's either one or more rings.
Right, one
and
plus.
then if it doesn't see anything,
then you know it's an A.
Okay, but then you're still guessing half the time.
You could 50-50 B or C, yeah.
Okay.
Yeah.
What if instead we look down from the top? So there's rings like that, and then if we look down with the LiDAR, then we can tell, okay, from ground, we know this distance.
Okay.
So then if there's one ring, we know that distance is X, Y, Z. So
And you're
for
not
one
guessing.
ring, yeah, for 1 ring, 0 rings, or 4 rings.
Okay,
or
I like it.
3. Yeah.
Yeah.
Okay, so we can do this.
So let's do that. Yeah, we can do that without vision. That's fine.
All right.
Erase this.
So then, continuing with the auto period, let's. I think we of course go to try to park on the launch line.
Yeah.
And then,
yeah, because you could do that.
yeah, just after we, yeah. And then, so the one thing to talk about for power shots versus goals is lining it up. So, the start line will either correspond more closely to the power shot targets or the goals. And we also, I suppose we won't have a teammate, so we don't need to talk about this, but other teams are going to have to be able to pick what they're able to do.
Yeah.
Based on what their start line is. Yeah.
Yeah, I guess since that's not a problem for us and the power shot targets are worth more,
Just go for the power shots.
I think, maybe let's prioritize power shots at the start.
Okay.
If we're going to launch anyway.
Yeah, I think we'll try to go for power shots, but if we're not able to, then we'll just try to shoot for the high goal.
Okay.
Yeah, because the surprise is that we want to make a shooter, like most teams, I'm sure. So we're going to be flinging rings. So then during the driver period, we'll of course also go for the 6-pointer. And then
So we're only aiming for high. Is that just because that's not only because it's worth most, right?
well, if you think about it, so for low goal or medium goal, you're going to still have to collect the rings. So you're either picking them up from the human player or you have to pick them up off the ground. So that's the same amount of time per.
Yeah.
And then actually unloading them, so I suppose if you're picking them up from the human player, you'll have to drive out to the launch line to launch them. But it seems as though it's still worth that 3 times multiplier to go for the high over the low.
Okay.
And if you want to shoot at the medium, you're going to have to shoot across your opponents, and you still have to get back to the launch line.
Sure.
So medium and high are basically the same thing. And then low, the advantage you get here is that you don't have to drive back to the launch line, but it's still 3 times less than the high goal.
Right.
So sticking with high makes sense to me.
Sure. Yeah. This one's good.
Cool. So then at the end, moving the wobble back
2 options with the wobble.
to the drop zone, which means moving it outside of the fence.
That might be tough for a weekend.
I think if we had more time, we'd want to go for it, but it's kind of out of the realm of our scope for a weekend.
Yeah.
But what we can do is we can
Push it around.
Yeah, we can push the wobble back to the start, so we can go for that. But once again, we should probably prioritize the bigger point scores. So we're going to want to go for the power shot targets.
Mm-hmm.
We're going to want to prioritize those.
Yeah, the other thing too though is like this is all driver control, right? So we could just when there's 5 seconds left or something, if we're not close to getting a power shot, we can just do this.
Yeah, definitely. Okay, so this is more like this is like 5 to 10 seconds left.
Yeah.
And that's what we just go to. So then the rings on the wobble. So this is another conversation we need to have. We need to figure out whether or not we want to pick up rings or if we would just want to rely on the human player.
I think picking up would be cool. I guess it sounds hard for a weekend.
Yeah, I think it might be valuable for us to just try picking up as kind of our reach goal. Because even if we can't,
Sure.
then I mean, we'll still have a functional shooter. So,
True. So build the. I guess I'm gonna grab one of these. Build I guess like build order or whatever.
Yeah.
Shooter. Well, let's not number them quite yet, but like shooter will be before a like picker upper.
Yeah. And then the other main component that we talked about is the ranging in order to figure out during auto period. So that's the other main component that I'm seeing. So we haven't talked about rings on the wobble yet. So depending on how we want to design our picker upper, we might be able to pick up and put rings on the wobble. But if we're only talking about 30 seconds, it's probably best for us to prioritize power shots.
Yeah.
But once again, this is one of those things where if you've got another teammate that is able to do power shots and able to do all 3 of them during the end, it's probably a good idea to be able to put rings on the wobble.
Yeah.
So we're not going to do rings on the wobble, I don't think.
Yeah.
But once again, it's one of those capabilities that you could probably figure out with more time. Cool. So we're gonna do a shooter, we're gonna do a picker-upper, and then we need to do a range-finding sensor for figuring out how many rings are stacked during the auto period.
I guess I would prioritize that second on this list for now.
Yeah, I think so.
I think we can probably concurrently work on these.
Mm-hmm.
I think even before all this, we need a robot that drives. So like we need a chassis.
Yep.
That's probably the first thing we'll want to do.
Yeah, and the other thing about the ranging is that we could make so if we had a ranger that points down initially, and then we put it on some sort of mount, we could pivot that mount 90 degrees, and then we could also use it as a shooting ranger.
True.
Yeah.
Yeah.
So that way we don't have to use a bunch of sensors, we can just use the one.
The thing is, well, all of our motors have encoders though too.
Oh, okay.
So if you could just
We just have a mechanical stop. Well, if we had a mechanical stop so that we just reset each cycle.
Sorry, what are we resetting?
So I would be worried about a servo wandering on us.
Drift stuff? Or
Yeah.
like slipping?
Yeah.
Wheel slip?
Well, I suppose servos are they?
I think you can localize where you are in the field without getting range on the walls, because you have the encoders to tell you how far each wheel's traveled.
Yeah, I'm skeptical of that,
Okay.
but we could try both. But I think having the ranger pivot wouldn't be too hard.
Okay.
And honestly, less coding. So
True. The other thing I guess you could do, Dan, like, remember those Lego Mindstorms had those like line following robots?
Mm-hmm.
That white launch line is pretty high contrast to the floor.
Mm-hmm.
That could potentially be used for a ranging thing. Of some
Right,
kind.
right.
It's pretty coarse, but
Right. But the other problem is that the power targets and the high goal are different heights, but we want to go for both of them.
true.
So we need to have more than one reference. Unless we want to change the strength of our shooter, but I think it'd be good to have a constant power shooter and change our distance.
Okay. So let's, I guess, try to do a ranger and shoot, or try for articulated.
So then we were able to look both horizontally and then look straight down.
Cool. Yeah, that
Um,
works for me. I think
sweet.
that sounds good.
So I think probably the next step is getting an idea of what parts we have and kind of what our chassis will look like. And then we can talk more about shooter design, ranging, and picking up after that.
Yeah, I guess maybe, can we brainstorm the chassis here a little bit?
Sure.
Before we look at all the parts. We should have enough. Oh, well, that's okay. Since particularly for the Ranger, I think is where it's going to come into play. That needs to be downward facing, right?
Mhm.
So I think that the chassis is going to have to be, well, if this is like a top view of the chassis, and you have your wheels here, I'll just draw 6 for now. Either you have to put your LiDAR on the side to look down, or you need to have an open space in the middle to look down on, and then you can mount your LiDAR here. Does that make sense?
Sure, what if we just made the chassis smaller than 18 inches, though?
Yeah, no, but I think your options are smaller than, you can either be less than 18
Yeah.
on the full width and put your LiDAR on the outside, or you could be 18 on the full width and put it on the inside as a U.
Right, I mean, what comes to mind for me is that our setup's going to be, okay, so we're on the start line right now.
Sure.
And then we need to go up here to range, so why not put the LiDAR, like, right out here? And then have this total length be 18, but our chassis
Sure.
only comes to, like,
Whatever it is.
15.
I think that would work fine if it weren't for the fact that Dan, unfortunately, CU Hyperloop has a very large LiDAR.
Ah, right, of course.
We'll do a video on the LiDAR specifically later.
And that's laser distance and ranging, something like that?
Yeah, I'll have to look up the acronym for sure.
Yeah.
But it basically measures, if an ultrasonic sensor, I'm gonna erase some here. So if you have like an ultrasonic here,
I'm going to erase this too.
sure. and that shoots out sound waves. They bounce off of an object, and then they come back, and it basically measures the time that it takes to come back. Since the speed of sound is known, LiDARs is pretty much the same concept, but instead of using sound waves or pressure waves, it uses a laser, so it uses light, and then it bounces back, and it just measures that.
Is it phase difference, or is it?
It's a time of flight thing, so I don't know. Yeah, time of flight. At least ours is time of flight. Yeah, we'll talk more about this later, and maybe some of the pros and cons of both of these. We're going to be using LiDAR because we don't have an ultrasonic. We only have LiDARs.
That's part of the reason why articulating it will be useful for us, because we only have one of them.
Yeah.
And it's a little bit expensive. So that's why we don't have two of them.
True. Yeah, I guess as far as the shooter goes, do you want to throw some ideas out on the shooter?
Yeah, sure. So the first thing that comes, let me go grab a ring.
Sure. Yeah.
Okay, so we've got these rings. First thing that comes to mind for me is flicking it like a pinball machine. That just seems like a really repeatable action. And these two can be coupled together. You can do it by gears, maybe a sprocket and chain.
That way you only need a single motor.
Yeah, single motor to reset something. I don't think we want a motor to do the actual torquing, but maybe something like a spring that could store that energy, that potential energy, and then quickly release it as kinetic. That's what comes to mind for me. What about you?
I guess other I think I like that. I think that's a repeatable option because you're not using the motors to actually launch it. You're using a set physical device. You're using the spring to actually launch it. So I think that's the way to go. I guess some of the other options that would come to mind to me, they have if you're doing like, Dan, what is it? It's not shot put because that's like
hurling
the like discs for shooting stuff.
When you say pull.
Yeah, when you say pull, and then yeah, it's like simulated pheasant hunting sort of thing. But it like basically launches this out because this single arm.
Clay pigeons.
Yeah, that's what it is. Clay pigeon basically like holds on to this thing, and then launches it out.
Kind of like a frisbee.
Kind of like a frisbee, except without the like sort of flick on there, and you can kind of adjust where. Obviously, you can adjust the angle that you launch it at, but then you can adjust where it goes in front of you based on like how far up this lever arm that you put it. So if it's here, it's gonna shoot out more this way, and if it's way at the end, it's gonna shoot out this way.
Well, I'm liking the physics of yours, and the reason I say that is that when you're trying to make something fly, it's not rotating. It's kind of tough to make it stay stable. But if you impart some sort of rotation, it'll self-correct and fly a lot straighter. So I do like the repeatability of mine more. I think that clamping and then having to release is kind of tough.
And I think that there's a lot more mechanical complexity in this one.
Yeah. What if we had something kind of like, what if we have a static wall, maybe with something kind of grippy on it, and then we had our ring touching, and then maybe our spring kind of pushes it into the wall, and that could impart some sort of spin on it.
I still feel like you're better off with your pinch.
Just two.
Yeah,
happening.
with your double pinch thing.
Yeah, I think spin might be helpful though. I'm not sure if maybe we don't have time to figure out spin, but pinch method, but somehow giving it spin might be would be the best thing. Yeah, we'll just have to kind of start to prototype and see what happens.
Yeah. The only other method that I can really think that's like fairly accessible for launching is sort of like your Hot Wheels method, where you have like some sort of straight track with these like spinning rollers, and these rollers spin, like this, and fling your ball out.
That is kind of my worry about kind of a different method that I thought about but didn't mention. Was having just a single punch in the back, so like a little flick.
Yeah.
So these are pretty compressible rings, and I think that might hurt your repeatability.
Yeah.
And that same thing might happen here, because if you remember with those Nerf, whatever, I can't remember the name of the Nerf.
Yeah, Rapid
toy,
Strike or something.
when it does that pinching, you kind of get this repeatability issue where not all of them pinch the same way. Some of them are already kind of like deformed, and then they go in at a different angle. And this is taking a lot of motors, a lot of power.
Right. Yeah.
So
yeah.
and what our RPM is only, so our RPM for our big motors is only 312, which per second is just shy of, what is that, 6 rotations per second? Yeah, it's less than 6 rotations per second, which is not that fast.
I don't know what the torque rating is, but yeah, you lose torque if you geared it up to spin faster too.
Yeah.
Yeah, I think we just have to throw that one out because I don't think we have enough motors anyway.
Yeah. Okay. So I think we're talking about a flicker.
I think we're talking about a flicker. The other nice thing about the flicker versus the flinger, Dan, well,
Flinger
from here
being
on,
the arm.
yeah,
That's
flinger.
the
Flinger is the single arm, like the clay pigeon stuff, and the flicker is the pinball style pinch.
Yeah.
I think the loading mechanism is way easier for the pinch. You basically just have to drop it into a spot.
Totally
Whereas this, you have to like
get it out along an arm somewhere.
and get it in, and then you have to position it repeatably so that you get it firing in the direction that you want, and that could be difficult. So I think the loader also gets a lot easier with the pinch method.
Yeah, I agree.
Cool.
Awesome. Do we want to keep on talking brainstorming, or do we want to figure out chassis first?
I'm thinking. I think
I'm
it's probably
nervous.
about. Go ahead.
I'm nervous talking about loading before we know what our chassis looks like.
Yeah. I think building up the chassis, like sort of finalizing that is going to be the next step.
Okay.
I think maybe lunch break first. And
Sounds
then,
good. Sandwiches?
Yeah, let's do sandwiches.
Okay, good.
Cool. Well, this was good. I guess we're gonna sign off for now from CU Hyperloop. So we will be back with more videos later. Make sure to tune into First Updates Now on YouTube to catch the rest of the videos from this weekend. Sweet. Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Thanks to all of our co-executive producers on Patreon and Tier 2 Plus subscribers on Twitch, keeping fun loud, live, and independent. Thanks to Robotics and Go Buildup for supplying components and providing on-stream giveaways.